let's talk about what a polynomial is first, and then we will just talk about linear polynomials and quadratics today. So in a polynomial, the exponents must be positive, and the exponents must be integers. So, for instance, let's take a look at this first one. So, is that one a polynomial? No, why not? Okay. So, how about B? Yeah. Well, I am sorry. I was just so busy talking about fantasy football league, which doesn't have anything to do with Precalculus, but I didn't give you your note page. Anybody else want to have one? All right. How about this one? B. Yeah. Now, what is this business? I said, if so, state the degree and leading coefficient. The degree of a polynomial is if you would put the highest powered term first, and then go in descending order. That's what we call standard form. And that highest degree of that term is the degree of the polynomial. So this is already in order, and I'm looking right here. So this is actually a degree 5 polynomial. What's the leading coefficient? Leading coefficient would be the coefficient of that highest degree, so it's 2. Okay. So how about letter C? Unless you can totally simplify the radical and get rid of its sign, it is not a polynomial. And at first you might think, well, but I can, because I can take the cubed root of 27x cubed. Yeah, but the plus 8, and you could actually do the cubed root of just that. But you can't simplify because of that plus there, because what that means is you'd have to find something that multiplies 3 times to be this whole thing. Okay, that's what a cubed root means. If it was multiplication, you could do it. This would be an example of something that's not, and the exponent would just be considered non-integer. Okay, so today if you're asked to rearrange polynomials in standard form, do you need me to talk about that? It just means you're going to list which term first? The highest degree, and then you're going to go in descending order. Okay. All right, so this is actually, a linear function is actually a polynomial of degree 1, because x to the first is x. And you might recall that they're of the form f of x equals mx plus b, or y equals mx plus c. Hopefully you've heard of that before. Just kidding. I'm going to kick you out of the class. All right, now, I actually want to add one more form to that. Do you guys remember what we call that? Slope-intercept form. What's the slope? M. And the y-intercept is B. I have another form called point-slope form. And point-slope form actually is kind of the precursor to slope-intercept form if you're given 2 points. In AP Calculus, actually in the AP test, they say everything can be left in point-slope form. And so, which is actually easier than slope-intercept form if you're given 2 points anyway. So I'm going to write that down. Okay. In point-slope form, I'm going to show you in a second. X1 and Y1 just represent one of the points. And what does M stand for? The slope. Okay. So let's just real quickly go through again, back from algebra, how we find an equation for a line, linear function means line, such that f of negative 4 equals 6 and f of negative 1 equals 2. What does that mean? Let's write these as points. What point is this? Negative 4, 6, and right? Isn't f of x, isn't that where the x is? Equals y. Okay. Cool. Would you guys find the slope of that? Those 2 points, please. So you may do, I always say y, rise over run. You've heard that before, right? Rise rhymes with wise, which means y coordinates. Okay? What? No, it doesn't. What are you talking about? Rise over run, rise rhymes with y. Okay, so I'm going to do the y's on top. It does not matter if you go y1 minus y2, but then you have to do x1 minus x2 on the bottom. Doesn't matter what order, but as long as you stay consistent. I'm going to do 6 minus 2 on top. That means I have to do negative 4 minus a negative 1 on the bottom. 6 minus 2 is 4. This is negative 4 plus 1, agreed? So the slope is negative 4/3. Good so far? Now I'm going to pick one of my points. Oh, I don't know which one. I'll pick this one. And I'm going to take that and this, and I'm going to put it in point slope form, and then I will show you how to distribute it too. So I'm going to write y minus the y coordinate. Y minus 6 equals the slope, which is negative 4/3, times x minus the x coordinate, or x plus 4. You may leave it like that. What if I did ask you to distribute, though? What would you, to get it to slope-intercept form? Well, that's not so bad. I have negative 4/3 x. Let's not shy away from fractions here. If I made that 4 over 1, that would be minus 16 over 3. Agreed? Okay. I need to add 6 to both sides, correct? I'm going to multiply 6 by 3 over 3 on top and bottom to get plus 18/3. Negative 16/3 plus 18/3 is plus 2/3. So this would be its point slope form. This would be its slope intercept form. I'm okay with today leaving things in point slope form, because that's what I would tell my AP calculus students. I will tell you though, tomorrow, like when you're checking your answers in the back, they're going to leave them in slope intercept. Okay. Questions? All right, good. Then I'm going to introduce quadratic functions. I'm not going to do all of the examples on the back, because we'll finish that up on Wednesday. So quadratic functions are degree 2. Ax squared plus bx plus c. They have a parent function of x squared, so they are called parabolas, right? When we graph them. Parabola. It sounds like Ebola, like that disease. Remember that? When everybody was scared that they got. Oh. All right, so A is the coefficient of x squared, B is the coefficient of x, and then C would be the constant. A little earlier this year, I talked about the quadratic formula song. X equals negative B. Okay, that's used to find the zeros. But the formula to find the vertex would be that key point where it turns. So the minimum of a parabola opening up or the maximum of one opening down, you can use this formula, and we did learn this in algebra. Negative B over 2A. And then for K meaning the y coordinate, you can do C minus AH squared. H is what we found here. Or you could plug H into the equation and find the y that way. This, that line that I'm highlighting right there is what we call vertex form. When something is in vertex form, then we have the vertex. This also kind of looks like what we were just doing with transformation, doesn't it? Didn't I just ask you to do something like this on your review? Isn't this just a parabola moved 3 units to the right and 1 up? And so all I'm saying now is I'm pulling that into here and saying, well, what that means is the vertex, because it was 0, 0, is now at 3, 1. All right. Just so you're understanding the parts of a parabola, let's say I'm going to draw something over here. I'm going to assume it's positive. I'm going to say that this is HK. Are you following what I'm doing so far? Okay. We have this thing that's called the axis of symmetry. The axis of symmetry is just the vertical line that goes through the x-coordinate of the vertex, which is why its formula is x equals h. It essentially cuts the parabola in half. All right. Actually, A and B is something I would have asked you for this example to do this past unit, right? Yeah, like B is more difficult. B is a reflection over the x-axis. What's the 2 in front? Vertical stretch of 2. This is right 1, down 7. I'm going to save these 2 examples because we've done this before for our notes on Wednesday, okay? I'm going to pick one of these. I'll pick A. A is already in vertex form. And I will pick C to show you how to use the AH squared stuff. Okay. Can you guys tell me, just from looking at A, what is the vertex? 1, 5, very good. X is a liar, and the formula is x minus h plus k. And so that would make, if that's the vertex, what's the axis of symmetry? X equals 1. It's just a vertical line that goes through the x-coordinate of the vertex. C is not in vertex form, so I'm going to use the formula that I gave you on the previous page. H is equal to negative B over 2A. So let's plug that in. What would go on top? Negative 2 over 2 times 2, which is negative 2/4, or negative 1/2. Agreed? Okay. Yes. That's okay. And then there's two ways that you can find the y-coordinate. You actually could plug negative 1/2 up in here for x because you're finding the y-coordinate when x is that value. Or you can use the formula that I gave you on the front, c minus ah squared, which would be negative 3 minus 2. I just have to remember order of operations when I do this. Okie dokie. So let's square this first. Negative 1/2 squared is 1/4, correct? Isn't 2, this is minus 2 times 1/4, that's like minus 3 minus 1/2? Isn't that negative 3.5 then? Goodness, it's so noisy over here. I know some of this you can do in your head, I'm just writing everything down. If you don't feel like you need to write everything down, that's fine. Okay, go vertex. H was negative 1/2, K is negative 3 and 1/2, so that's my vertex. And then the axis of symmetry. X equals negative 1/2.